Today is December 15, 2024. So today we'll talk about basic syntax, variables, and operators in Python. So it's part of our first module, Python Basic. So start with our first topic, Python Basic Syntax. So first of all, what is syntax? Syntax is the structure of the language. So first of all, Python is case sensitive. What does that mean? Let's see one example. Suppose I define a new variable called x. Then I define another variable also called x, but this time I use capital letter. And capital X is equal to a list of numbers 1, 2, and 3. Okay. So now let's see if little x is equal to capital X or not. False, right? So that means little x and capital X are two different variables. So when we define variables, be careful. Python is case sensitive. Lowercase and uppercase letters are different. Let's see another example. How about values? So now let's define two new variables. Y is equal to quote A. So Y is a character variable. And Z is equal to quote capital A. Now let's see if Y and Z are equal. Apparently no, they are not equal. So Python is case sensitive. Next, let's see semicolons. Sometimes you want to put multiple statements on a single line. In that case, you need to use semicolons to separate these statements. So for example, let's create two variables and calculate the sum of them immediately. X is equal to 4, Y is equal to 6, and then X plus Y. So you see, these are actually three statements. If we want to put them in one line, we have to use semicolon to separate them. So let's run it. You see we get 10, which is correct. Next, white space. So white space in Python sometimes matters, sometimes doesn't matter. Okay, so let's see. First case, within line, white spaces don't matter actually. So let's see one example. Let's define a variable called x again, which is equal to 10 minus 5. And then we define a new variable, which is called y. So now let's insert some white spaces in between the characters. So y is equal to 10 minus 5. Then let's check if x is equal to y or not. By the way, so this double equal means comparison. So check whether or not the left term and right term are equal. So it will return a logical value, either true or false. So let's check. True, right? So white space within lines doesn't matter. So how about indentation? It actually matters. In Python, whenever we use a loop or define a function or conditional flow, we need to use a colon to start those procedures. In that case, indentations will be automatically added to your program. Let's see. For example, let's write a for loop for I in range 3. Colon. Print I. Okay, so this is a very mini loop, a for loop. So range 3 is a list of numbers from 0 to 2. 0, 1, 2, not including the end number, the end point actually. So let's run it. You'll see in each iteration, it will print the value of I in that iteration. So notice that after we typed this colon, there is an indentation automatically inserted in the second line. So these are also white spaces, and they do matter. You have to have these indentations to indicate that this statement is within this for loop. Okay, so it's automatic. All right, next, comments. There are three formats of comments. First, inline comments. We have seen examples previously already. Let's just review it. For example, I define a new variable called x. X is equal to 5. Then immediately we can add a comment. Define a variable. And then you see whatever behind this pound key will not be shown after you run the code. Then the second format is standalone comment. So for example, we can say define a function. So later on, we will learn how to define functions by ourselves. So now let's see a very simple example. So we call the def function to define a function. Suppose we want to create a function to calculate the sum of two numbers. We can just call the function addition, and then parentheses, type the argument that are needed for the function, then type colon, then return x plus y. Then the function addition has been created. We can call it. For example, calculate the sum of 3 and 5. You see, we get 8. So apparently this is a standalone comment. Use the whole line. Occasionally, we need to insert multi-line comments. For example, you want to describe a big chunk of code in your report. So in Python, actually there is no specific syntax for multi-line comments, but you can use triple quoted strings, either single quote or double quote. For example, if we want to include 3 lines of comments, we can do the following. So notice that if I type a single quote a few times, we'll see these 6 quotes. Okay, then I can hit the enter key and separate them. Then we can start to write comments. For example, this part is about regression, and we will use backward model selection to find the optimal model. Okay. And then let's type some code, random code. Print regression is fun. Then let's see what happens. Run it. So you see only this line is executed. Everything that is wrapped in this triple quote is not executed. And then next topic, parentheses. Parentheses can be used to group statements or math operations. So this is our common sense, right? For example, if you want to calculate 10 times the sum of 2 and 3, then we use this notation. We can run it and get the result. And parentheses are also used to call functions. Let's see another example. Define a list L, which is equal to 5, 4, 3, 2, 1. And then let's print the first element of L. So we can first print a string. The first element of L is type comma, and then let's pull out the first element. Python uses zero-based index. So if the first element has index 0. Okay, so let's run this. As you see. And the point here is we use a pair of parentheses to call the function print. And sometimes in Python, you will see that arguments are not required. Basically, you can use an empty pair of parentheses to call a function. For example, let's see. Suppose we first call the sort function to sort L. And then let's call the print function again and see after we sort out what happened. Okay. So apparently after we call the sort function, L is sorted from 1 to 5 using ascending order by default. Okay. And after we sorted, the first value is 1 instead of 5. So the point is sometimes when you call a function, you don't have to include any arguments in the function. It looks weird, but it is allowed in Python. Okay. But actually, you see there is a default argument, which is L. Okay. We are sorting L. But when you use the dot syntax, so you start with an object and then called method or application to apply on the object. So in that case, it seems that there is no argument. And lastly, in basic syntax, let's see how to check your version of Python installed. So first, you just need to import the sys package. So this is a built-in package. You don't have to install it. Then you can just print sys.version. You can see your current version of Python. All right? So this is part 1. Now let's move on to the second topic, Python variables. So first, let's see how to assign a variable. We can just use the equal sign. For example, x is equal to 100, and then type x. So it has been defined. So now let's pay attention to the rules for naming variables. You can use a combination of lowercase characters, uppercase characters, digits, and underscore to create a variable name. So till last example, we only use single English letters to define variables. But actually, you can also use numbers and underscore. For example, let's create a new variable called my pet. Okay. So it's equal to Teddy. So this is my dog's name, Teddy. Okay. Then, so my pet is Teddy. Okay. It's a character string, the value. Okay. And secondly, names of variables in Python are case sensitive. So my pet and my pet are different. So for example, if we create a new variable called my pet is Dodo. Okay. And then got my pet. So you see. And if you want to call my previous definition, my pet again, you see it was not overwritten by the new definition. Okay. And thirdly, Python has a total of 35 reserved keywords. For example, if, else, def. So this is used for defining functions. And while, so this is a keyword for a while loop and for loop. So you cannot use them to define a variable. So for example, if we try to use it for is equal to 5, you see what happens. You see invalid syntax. You cannot define a variable called for. Okay, pay attention to that. Then let's see styles of variable names. For beginners, it's very helpful to have a consistent programming style. So there are 2 basic styles of variable names. The first one is camel case. So it's kind of like a camel, up and down. So you capitalize each word except for the first one. And snake case, just use underscore to connect different letters or words or digits, etc. So all of them work. And the last one is kind of special, is used for constants usually. If you use all capital letters, that means that variable is actually a constant. So lastly, Python variables are pointers. For many other programming languages, variables are containers, like a bucket. But in Python, variables are pointers. Let's see what does that mean. So let's first create a variable called x and let it be 1. Then probably you change your mind. You want x to be a character string, apple. Right. And finally, you change your mind again. You want it to be a list of letters, A, B, and C. So all of them are valid code. So Python will have no objection to your definition. Then let's see what x is actually equal to by typing x. So the last definition works. The previous 2 definitions were overwritten. So which means Python is very flexible in terms of defining variables. It's kind of like a pointer. X was first pointed to 1, the integer 1. And then you change the direction and point x to a character string apple. And lastly, you point x to a list of characters A, B, and C. Okay. Then the last definition will be the final definition of x, unless you change it again later. So that's why Python variables are pointers. And notice that in these three definitions, x has different data types and different data structures. So it doesn't matter. Python is very flexible. You don't have to predefine the data type and structure before you define a variable. So lastly, let's talk about Python operators. There are 4 types of operators: arithmetic operators, comparison operators, Boolean operators, and membership operators. Okay. First, take a look at arithmetic operators. So this table contains most of the arithmetic operators. The top 7 are called binary operators because they require 2 terms to do the operation: addition, subtraction, multiplication, division. So these are very basic. And then we have floor division, which will be the quotient of A and B round down to an integer. Okay, so let's see one example of this. So let's first calculate a regular division, 5 divided by 3. Okay, so this is the true quotient. So then let's see how floor division works. Calculate 5, floor division 3. Run it, we got 1. So we know that if we round the result in a regular way, it will follow the 0.5 rule. But floor division always round down, apparently. So it's quite special. Then let's take a look at modulus. Modulus will return remainder after division of A by B. Okay, so for example, let's check 5 modulus 3. Run it, we got 2. This is remainder of 5 divided by 3, which is definitely 2. And exponential, this is also very familiar. Let's see, 5 to the 2, okay, 25. There are 2 special operators listed here. They are unary operators, which means you only need to have 1 term. So negation, so this is unary minus or negation, the negative of A. Okay. So for example, let's say A is 5 and then minus A. Okay, you get negative 5. Okay. And last one is matrix product. Okay. There are a lot of more matrix operators available in Python, but in our class we rarely will use them, so I won't talk about them in details. And the second type of operators is comparison operators. Okay, we have seen double equal, right? So the value that will be returned by comparison operations is a Boolean value, either true or false. So equal. Pay attention, you need to use double equal. If you use single equal, that will be an assignment operator. You will assign the right term to the left term. So that's assignment. If you want to do comparison, you have to use double equal. And this means not equal. Less than, greater than, less than, equal to, greater than, equal to. Let's see some examples. For example, let's first create 2 variables. X is equal to 5 and Y is equal to 5. Okay, let me just get rid of the... And then let's check if x is equal to y. Okay, true. Okay. And see another example. Suppose, let's check if x is not equal to y or not. False, okay, because x is equal to y. So now let's define a new variable z, which is equal to 10. Okay. And then let's compare x with z. Okay, check if x is less than z or not. We got true. And also, if we want to check if x is less than or equal to z or not, we also got true, okay, because it's less than. Okay, it's one of the 2 cases, less than or equal to. All right, next, Boolean operators. Sometimes you have multiple comparison statements. For example, you want to specify some conditions in a conditional flow, you want to connect or combine multiple comparisons together. In that case, you need to use these Boolean operators. There are 3 of them, and, or, and not. So let's see, for example, we have a variable called x, which is equal to 4. Then we want to check 2 things at the same time. X is less than 6, and x is greater than 2. And the result is true. That's because both of these 2 are true. Okay. So and means intersection. Only if both of them are true, the result will be true. The next one, or. Okay. So let's see, y is equal to 21. Okay. So let's check the following 2. Okay. X is greater than 10, or x modulus 2 is equal to 0. Okay. So let's check this. This one apparently will yield a false, okay, because x is 4. Okay, so false. And how about the right one? Okay. X is equal to 4. So 4 divided by 2, the remainder is 0. So 0 is equal to 0. So this one will yield a true. False or true will be true. Okay. So or operates in that way. As long as one of the 2 statements is true, then the result is true. The overall result is true. So let's run it. And you see true. And how about not? Okay. Not will negate a comparison result. So for example, not y is greater than 20. Okay. Y is greater than 20, which is true, right? And if we negate the result, we get false. Okay. All right, next, membership operators. There are 2 membership operators, in and not in. So A in B is true if A is a member of B. Okay, we'll see the meaning of member in a moment. And A is not in B is true if A is not a member of B. So let's see one example. 1 is in the list 1, 2, and 3. So check it, true, right? Because 1 is indeed one member of the list. So now let's check not in. Okay, 1 not in 1, 2, and 3. And we got false. Okay, because 1 is in it. Okay, so this statement is not true. So that's why we got false. And if we check 0 not in 1, 2, 3. Okay, we got true because 0 indeed is not in the list. Okay. So how about a smaller list? Let's check. 1, 2, in 1, 2, and 3. Okay. It seems that 1, 2 is in 1, 2, 3, right? Let's check it. Unfortunately, it's false. That's because in the list 1, 2, 3, each element is a single integer, is a single number. So 1, 2 itself is not one element of the list. Okay. You can say it's a kind of a subset of it, but it is not a member of 1, 2, 3. Members are these single integers. Okay. But if we define the list in this way, for example, check 1, 2 is in 1, 2, and we define a sublist here. Okay. So this is legal because list is very flexible. When we talk about data structures later, we'll talk about lists. Okay. So the third element is a smaller list called 1, 2. In this case, if we run it, we get true. Alright, that's all for this video. Thanks for watching. If you think this video is helpful, please like the video and subscribe my channel, Dataflow. See you next time.